Today we're diving into another important part of structural steel design, welded connections. Let's take a closer look at how welded joints work, how they're designed, and why they matter in steel construction. So what are welded connections? Welded connections are a method of structurally joining steel components. The parts to be connected are heated and fused, and a supplementary metal called filler metal is added to the joint. When cooled, the base metal and the weld act as one continuous structure. One common process class is the shielded metal arc welding or SMAW. An electrical current arcs between an electrode and the base metal, melting both. The electrode is coated to form a protective gas shield, preventing oxidation. As the weld cools, slag forms and must be removed before painting or applying another weld pass. So let's talk about fillet welds. These are among the most common types of welds and are often triangular in cross section. The design is based on a 45-degree right triangle, while fillet welds can resist various types of loads. They are weakest in shear, and failure is assumed to occur through the throat in shear. So to determine the shear stress, we use the formula we use this formula FB is equal P over 0.07 WL. So this one is the area. So it pertains this tributary area. So yung throat dyan is this lanting na nakabase sa 45-degree right triangle. So, makukuha natin yung dimension ng throat by the cosine 45-degree is equal to throat over the thickness W. So, kung isi-simplify natin yung cosine 45, it is equivalent to 0.707. So, to simplify, ito na yung formula natin. Then, this slide compares the minimum size requirements for fillet welds as specified in two versions of the NSCP. Yung first table is based on NSCP 2001, while yung minimum size ng fillet welds naman dito is based sa NSCP 2015. But we're going to focus on NSCP 2015. So, sabi dito sa table, pag yung base plate mo has a thickness na mababa sa 6 or equal sa 6 mm, yung magiging minimum size niya is 3 mm. When the thickness is over 6 to 13 mm, the minimum size of fillet weld is 5 mm. Over 13 to 19 mm, the minimum size of fillet is 6 mm. Then the rest, pag over 19 mm na, is yung minimum size natin is 8 mm. So, the minimum size of a fillet weld must be enough to carry the required load and must follow the values in table that I've shown previously. So, the maximum size depends on the thickness of the material. So, dito sa 510.2.2.2, which is the limitations. So, pinabanggit dito naman is yung maximum size ng fillet weld. For materials less than 6 mm thick, the weld size must not be larger than the material thickness. So, for materials naman 6 mm or more, the maximum size thickness minus 2 mm. So let's say for example, yung base plate mo is 10 mm, yung magiging maximum, so pinag-usapan is yung maximum size ng fillet welds mo. So 10 minus 2, it is equal to 8 mm. So therefore, yung maximum size ng fillet weld mo is 8 mm. So why these rules matter? Two small welds may fail. Two large welds may cause excessive heat distortion or waste of material. So following these limits ensures structural safety and efficient fabrication. So this excerpt explains design requirements for fillet welds. So yung minimum effective length must be at least 4 times the weld size. Otherwise, the weld size is reduced to 1/4 of its effective length. For longitudinal fillet welds naman, for tension members with end connections, each fillet weld must have a length at least equal to the spacing between them. Then for end-loaded fillet welds naman, for weld lengths up to 100 times the weld size, the effective length equals the actual length. For weld lengths greater than 100 times the weld size, a reduction factor beta is applied, which is equal to 1.2 minus 0.002 times L over W. Then this value should be less than or equal sa 1.0. When the weld length exceeds 300 times the weld size, beta is fixed at 0.6. Pag nag-exceed na siya sa 300 times ng leg size, yung beta natin is magiging 0.6. Yung key point dito, class, longer welds don't proportionally increase strength because the load distribution is not uniform, hence the reduction factor. So, in actually loaded welded connections, we compute the design strength based on the NSCP 2015. This includes strength based on gross and effective area of the member, the design strength of the weld per millimeter, and the shear strength of the base metal. Yung first formula natin is yung force carried by weld. So, yung FB dyan is the shearing stress at the throat kasi nandun yung tributary area mangyayari doon sa throat ng fillet. Ito yung throat. Then yung area natin, so it is equal to 0.707 times the thickness ng fillet weld mo times length. Then, the second formula is the force per unit length of the weld. So, Q is equal to P over N. So, yung unit niyan, class, is naka-Newton per mm. So, ang U natin is also equal to 0.707 times T times FB. Kasi we know that the unit for the shearing stress is naka-Newton per mm squared. Then, multiply mo yung thickness nito na mm. So, maka-cancel out yung isang mm. So, therefore, naka-Newton per mm yung units nito. Then, dito naman, it stated here the design strength as per NSCP 2015. So, ito, papakita ko na lang. Pero, meron tayong summarized version nito. So, ito class yung design strength NSCP 2015. Pag yung design strength of the member to be connected by welding to a gusset plate, pag based on gross area, so ibig sabihin yung kinukuha dito is yung design strength ng base plate. Pag based on gross area, we use this formula Fy times Ag. So, I know that you're already familiar with this one since na-topic na natin yan in our prelims. Then, again, the reduction factor we use for LRFD is 0.90, while for ASD, we use the safety factor equals to 1.67. Then, pag base naman sa effective area, we use this formula FU times AE. So, meaning this one is the effective area equals U times AN. Then, yung reduction factor is 0.75, while the safety factor is 2 is 2. Then, the next design strength is based on the weld per mm. So, we use this variable Qn to represent the weld per mm. It is equal to 0.707 T times Fw. So, yung Fw dyan is the ultimate stress of weld. Pag hindi given yung Fw, then meron lang is yung Fu. We use this value of 0.6 times the Fu. Then, again, para naman sa reduction factor, we use 0.75. Then, ASD of safety factor na 2. Then, design strength naman based sa metal shear strength. So, sa shear strength ng metal. So, yung Qn dito, so pag mga Q-class, ang tatandaan nyo, lagi yan naka Newton per mm ang unit. So, use 0.6 times Fy. So, siya yung shear yield strength. No? So, 0.6 Fy. Pagka yield, syempre yung gagamit mo is yung yield stress. Kaya Fy yung gamit. Then, yung reduction factor is 1. Then, sa ASD, yung safety factor is 1.5. Then, sa shear, so dalawa yung babasehan natin sa computation. Dalawa yung i-check natin. Yung base sa shear yield strength and base naman sa shear rupture. So, sa rupture, di ba, pagka rupture gamit natin lagi is yung ultimate stress na Fu. So, yung formula naman dyan is 0.60 Fu times T. Then, ito naman class yung mga safety factor and reduction factor. Then, design strength naman of the connection with longitudinal and transverse weld. Pagka sinabi nating longitudinal, for example, meron tayong plate, tapos connected siya by the welds. So, ito, yan. Ito yung mga welds. Diba? From our previous discussion, ito is considered as the longitudinal welds or longitudinal length, lalo pagka subjected to tensile force. Ito naman is yung transverse welds. This one, same lang din na longitudinal. So, dalawa din yung i-check mo. Yung formula na P is equal Q times L. So, itong Q, alam natin na 0.707 times Fw times T. Then, i-check mo din siya dito sa P is equal to Q times 0.85 times the longitudinal length. Ito is the longitudinal length. Plus 1.5 times Q times T transverse weld. Transverse length, I mean. So, pagka nasolve na natin yung pareho equation, yung pipiliin nyo dito class is yung bigger value always choose the bigger value. Pag dito naman, sa dalawa na to, ang pipiliin mo is the smaller value. Then, lastly is the block shear strength of welded connection. So, pagka block shear naman ng welded connection, dalawa din yung i-check mo. Yung Rn is equal to 0.6 Fu times A and B plus Fu A and T. Yung isang formula naman is Rn is equal to 0.6 FyAgV plus Fu times A and T. Then again, ito naman yung ginagamit na reduction factor and safety factor. So dito sa dalawa, pipiliin mo naman is yung smallest value. So yung ito lang isa yung kailangan mong piliin is yung malaking value. So let's have a sample problems para ma-apply yung concept.